Hello students, now we will discuss heat and thermodynamics. Heat and thermodynamics, some definitions. Heat capacity, the amount of heat required to raise the temperature of the body through 1 degree C without changing its state is called heat capacity of the body. Next one is specific heat. The amount of heat required to raise the temperature of unit mass of substance through 1 degree C without changing its state is called specific heat. Mathematically, specific heat is equal to heat capacity upon mass of the body. Specific heat depends upon the nature of the substance. It does not depend upon the size or mass of the substance. Now units of specific heat in SI system, units of specific heat is joule per kg per degree Celsius. In CGS system, units of specific heat is erg per gram per degree Celsius. It is also measured in calorie per gram per degree Celsius, where 1 calorie per gram per degree Celsius is equal to 4.2 joule per gram per degree Celsius, or it is equal to 4200 per kg, 4200 joules per kg per degree Celsius. In case of gases, there are two types of specific heat. Number one, specific heat at constant pressure. Symbol is Cp. The amount of heat required to raise the temperature of unit mass of gas through 1 degree C at constant pressure is called specific heat at constant pressure. Number 2, specific heat at constant volume. The amount of heat required to raise the temperature of unit mass of gas through 1 degree C at constant volume is called specific heat at constant volume. Note is Cp is always greater than Cv. Now molar specific heat, the amount of heat required to raise the temperature of 1 mole of substance through 1 degree C without changing its state is called molar specific heat. In case of gases, two types of molar specific heats are: number 1, molar specific heat at constant pressure, Cp, capital Cp. The amount of heat required to raise the temperature of 1 mole of gas through 1 degree C at constant pressure is called molar specific heat at constant pressure. Number 2 is molar specific heat at constant volume, capital CV. The amount of heat required to raise the temperature of 1 mole of gas through 1 degree C at constant pressure is called molar specific heat at constant volume. Relation between Cp and Cv is Cp minus Cv is equal to capital R upon J, where capital R is universal gas constant and capital J is Joule's constant. So this is the relation between Cp and Cv. Now number 1, heat equation. By definition of specific heat, heat required to raise the temperature of 1 gram of substance by 1 degree C is equal to C, the specific heat of the substance. Therefore, heat required to raise the temperature of m gram substance by 1 degree C is equal to mc. This is by unitary method. And also heat required to raise the temperature of m gram substance by theta degree C is equal to mc into theta. That is, heat Q is equal to mc theta. This is the heat equation. Now specific heat of an alloy. Let an alloy consist of two metals of masses m1, m2 and specific heat C1 and C2 respectively. If the temperature of the alloy is increased through theta degree C, then the amount of heat required by first metal is given by Q1 is equal to M1 into C1 into theta. Let it be equation number 1. And the amount of heat required by second metal is given by Q2 is equal to M2 into C2 into theta. Let it be equation number 2. If C be the specific heat of alloy, if C be the specific heat of the alloy, then the total amount of heat required to raise the temperature through theta degree C is given by Q is equal to M1 plus M2 total mass of the alloy into C into theta, and it is equal to Q1 plus Q2. Putting the values from equation 1 and equation 2, we get M1 plus M2 into C into theta is equal to M1 into C1 into theta plus M2 into C2 into theta. Therefore, M1 into M1 plus M2 within the bracket into C into theta is equal to M1 C1 plus M2 C2 within the bracket into theta. Now theta and theta cancel each other. Therefore, we get C is equal to M1 C1 plus M2 C2 upon M1 plus M2. Let it be equation number 3. This gives the specific heat of alloy containing two metals of masses M1 and M2. Similarly, if an alloy consists of n metals of masses M1, M2, M3 and so on, Mn, and specific heat capacities C1, C2, C3 and so on, Cn respectively, then the specific heat of the alloy is given by C is equal to M1 C1 plus M2 C2 plus M3 C3 plus so on up to plus Mn Cn whole upon M1 plus M2 plus M3 and so on plus Mn. So this is the relation for specific heat of the alloy containing n metals. So thank you very much.